Welcome back. So today I'm going to continue our conversation about probabilities on categorical variables. What I have here is two categories. One is called gender, and the other one is called the school you go to, whether you go to a high school or to a college or doing some graduate studies. I should have said GS, graduate studies. So maybe you're working on your master's. Maybe this is your little town where you live. And so what I have here is I throw at you 6 numbers. Don't look at the numbers in blue, okay? So those didn't exist before. Oftentimes we give you one category called gender against another category called the level at which you study, whether you're in high school, college, or doing graduate studies. And so, and we want to calculate some probabilities. So you might ask, why do we care about those probabilities? We do care about them because oftentimes schools or hospitals or institutions or business entities, they want to figure out how much resources they need. So, for example, for a school, they want to know how much food they should order. They want to know how many teachers they should hire, how many aides, like teaching assistants, resources like computers, desks. If you go to a hospital, how many beds, how many rooms, what kind of food the cafeteria should have. And we take a lot of surveys and we want to find probabilities so we can predict our needs. If you are short on your needs, you've got a problem, right? You have people who are very unhappy with you. Imagine a class with 60 students because the school didn't foresee that they're going to need to hire more teachers of, let's say, history. And also too much is problematic because you end up wasting resources. Imagine you make cell phones, okay? And you did not do your research to find out, to understand your markets. So if you have a shortage of phones, you're going to lose a lot of profits. Imagine Apple makes 1 million phones and then realizes when the phone is on the market that they are short. The line is long. People now have to wait for 6 months because they didn't make enough phones. You get angry customers and also you lose profits, you lose money. Now, the converse is true. If you overdo it, so let's say you produce 10 million phones and then you realize you only needed 1.5. Now you're going to lose a lot of profits, okay? So it is so important to learn how to figure out probabilities. So I just made up this little story. You have gender against the school you go to, and I have these 6 numbers. So before you find any probabilities whatsoever, the very first thing you need to do is add up the columns and add up the totals and put them on the margin. So we know, for example, this number reflects the number of students of males in high school. That's the number, not the probability, just the number of people, of males or men in high school. That's 100. But if you want to know what's the number of kids in high school, regardless of the gender, you just add up these numbers. So when you add this 250 is the number of students in high school, number of kids in college, irrespective of the gender, number of students taking graduate classes, irrespective of the gender, number of males, irrespective of what school they go to, number of females, irrespective, right? So these 5 numbers are very important, and the way you get them, if you add these numbers, you get 310. If you add these numbers, you get 350. Add. Now, this number shows up from nowhere. I call this the grand total, and I underline it 3 times. So if you add the number of males to the number of females, we're going to get 660. In other words, we have 660 people, period. If you add the number of kids in high school, and number of kids in college, and number of kids in graduate studies, you should also get 660. So if you add these three numbers, you get 660. And if you add these three numbers, you get 660. Now, it's important to verify it both ways, because a lot of students say, well, we know that the grand total can be obtained either this way or that way. Let me just do this, is much faster. That's good. That's correct. Logic is good. The problem is, if you made a mistake here and call this 120, then these three numbers will add up to 670, not 660. So it's important to verify the totals in both directions to see if it is 660. Once you get those marginal values, or these numbers on the margin in blue, the numbers on the margin, they're never given to you. They usually give you just this. This is a 2 by 3 matrix. Okay, it's 2 rows, 3 columns. It's a 2 by 3 matrix. Very quickly get those 5 blue numbers, and of course either add these or add these to get 660. Now you're ready to go. Now you couldn't do a Venn diagram here, because we don't just have one thing against another, right? So this is a little more complicated. If you're not sure, go back to the previous presentation that we did synchronously. Go over that first and then come back to this one. So let's begin with some simple questions. What's the probability of being a male? Remember, we write the probability. This is a function P. It's like F, okay? It's just a function. Don't get scared of P. It's just a function, okay? P of being a male. Probability of an event is a real number between 0 and 1. So what's the probability of being a male? Well, the probability of being a male, this is the number of males, irrespective of where they go. So it's 310 divided by the grand total. Now, you may want to divide this by this and get the percentage. It's very close to 50%, maybe 48%. So you could leave it like this, or you can write it as a percentage. What's the probability of being in high school? When I say in high school, I didn't say whether you're a male or a female, so you don't care. You just go to the high school. This is the number of kids in high school, irrespective of the gender, and you divide by the grand total. It's very simple. 250 over 660, which is another percentage. It's probably around about 40%, give or take. How about this? Now I'm going to introduce and. This is called a conjunction. What's the probability of being a woman and in graduate studies or in graduate school? So the way you do it, you go to women and you go to graduate studies and you find that intersection. Because you have to be a woman, you have to be on this row, and you have to be taking graduate studies. So when you intersect this line with this line, you get 60. That is the number, but I'm not looking for the number of students, of women in graduate studies. I'm looking for the probability that if you encounter a person at random, that person is a woman and is doing graduate studies. So you take 60 and you divide it by 660. And this is around 10%, give or take. Notice all the answers are numbers between 0 and 1, as you would expect. Inclusive, you could have 0, you could have 1. Here is an example where you have 0. What's the probability of being in high school and being in college at the same time? Well, these are independent events. So when you combine this with this or this with this, you will always get 0. So you can't be in high school and in college at the same time. I know sometimes high school students take college classes, but that's not what I mean. I mean you are an actual student at the university studying to get a bachelor's of science or a bachelor's of the arts, and at the same time you are in high school. Well, there is no intersection. Remember what I just did. I had women and graduate studies. Those two lines intersect at 60. Now, these two lines don't intersect at all. They're parallel. So we call these independent. We call these independent. We call these independent. We call these independents. I'm basically saying you cannot be a male and a female at the same time. Now, I know we can get into a different conversation here, but bear with me. We're talking about here the sex, okay? So the probability that you are in high school and you are in college at the same time is 0. As I said, the values have to be between 0 and 1 inclusive. So in this case, I got 0, okay? So let's make it a little more complicated. What's the probability of being a male or being in college? Now, I want you to visualize this with me. With Venn diagram, it was very easy to spot. And of course, you never have to do what I'm going to show you now. There is a formula. But for now, we said being male or in college. Either being a male, which is this plus this plus this over this, basically 310 over this, right? 310 over this is this over this plus this over this plus this over this. Or being in college, this plus this over this, basically 300 over 660. But watch the pencil and watch what's going to happen with 160. So I am not going to say being a male is 310 over 660. I'm going to deliberately say 100 over 660 plus 160 over 660 plus 50 over 660. I know it's 310 over 660, but I'm going to break it apart. So here it is. Being a male will be this over this plus this over this plus this over this. Being in college, it's this over this, which is also this over this plus this over this. Did you see what happens to this number here? I counted it twice, didn't I? I'll repeat. This over this plus this over this plus this over this plus this over this plus this over this. So because we counted this over this twice, we're going to remove it once. Okay? And that was obvious when we worked with Venn diagram. We had two kids taking math and kids taking science. So the way you do it is you find the probability of being a male and you add, these are numbers, okay? So you have to add and subtract. So you don't say or, you add. So probability of being a male plus the probability of being in college minus the probability of being in both. This is the intersection. This is the one in both. This guy happened twice. This over this happened twice. I'm actually going to write it for you so you can follow me. So being a male or being in college. Being a male is 100 over 660 plus 160 over 660 plus 50 over 660. Now you might say, well, why don't you just say 310 over 660? Yes, I could, but I'm writing it this way for a good reason. Or in college. Well, being in college, it's this number over this number. However, I'm not going to say this. I'm going to say this over this plus this over this, okay? So, this is being in a male. Plus, or means you add. Being in college. Well, being in college is 160 over 660 plus 140 over 660. Do you see how we have this written twice? So we're going to remove it once. We're going to remove 160 over 660 once, because you can't count it twice. And that is exactly this one. We're going to remove 160 over 660. Because what's the probability of being a male and being in college? Well, being a male and being in college is 160 over 660, which is exactly what we need to remove. So So this is the formula, okay? The probability of A or B is the probability of A plus the probability of B minus the probability of A and B. So you've got to remove it one time, okay? So being a male, we did it. It's 310 over 660. Being in college, it's 300 over 660. Minus being in both. Both means here and here, which means this over that. So we're going to subtract 160 over 660. I got 450 over 660. And now I started doing percentages, okay? If I divide this by this, I got 68.18%, okay? Next one is complements. The complement of being a female, a woman, is called W to the power of C. The probability of the complement of being a woman. The complement of being a woman means being a male, or just 1 minus the probability of being a woman. Okay, we did that before. So the probability, I'll write it here, the probability of A complements is 1 minus the probability of A. Watch the previous video and I went in detail about this. Okay? So 1 minus the probability of being a female or a woman. Now, being a woman happens to be 350 over 660. 1 minus 350 over 660, which is 310 over 660, which is exact probability of being a male, right? Because in our case, the complement of being a woman is exactly the probability of being a male, because it is a binary. If you're not a woman, you are a man, and if you're not a man, you're a woman in our case, yeah? So that's why we got 310 over 660, which gave me 46.97%. Now, the next one is conditional probability, which we also did before. But now we don't have Venn diagram. That's why I'm doing this problem. What's the probability of being in graduate studies given that you are a woman? And I'm going to show you this in two ways, and I really want you to pay attention with me. What's the chance that you are in graduate studies provided that you are already a woman? So what do? We only look at women. Only look at women. Out of these women, how many of them are in graduate studies? It's 60. So the probability is 60 over 350. Which gave me about 17.14%. This is the very first time the denominator is not the grand total. So if you look here, 660 here, 660, 660. Even this one, it's 0 over 660. Isn't that true? Which is 0 or 0%. 660, same, right? First time, the denominator is not same. All it means is, given, you start here, okay, you start with the given. Given that you are a woman, in other words, you're only considering women. Pretend we go to this city and we tell all the males, go away, go camp. I don't want to see you. Everybody, leave. Nobody's here. All the males are gone. We only have women, okay? So these people went to camp. They're not in the city. Now, provided that you are a woman, because the only women we have is 350. Provided that you are a woman, what's the chance that you encounter somebody in graduate school? There is a 60 out of 350 chance. Because these are not in graduate studies. Even though they are women, they're not in graduate school. Okay? So, out of all the women, how many of them are in graduate studies? 60. So the percentage is 17.14. Alternately, you can use the formula that we did last time. The probability of being in graduate studies given being a woman is the probability of G and women, graduate studies and women, divided by the probability of being a woman. This is a formula, okay, which I did last time. Probability of A given B is exactly the probability of A and B divided by the probability of B. That's the definition of conditional probability. If I do it that way, I will get the same answer. Let's see. What's the chance of being in graduate studies and being a woman? So we did that before. A woman and graduate studies. It's 60 over 660. In fact, here it is. We did it before. Got it? So I write it here. This is exactly this. That's not the denominator. That is the numerator of this fraction. So this stuff here is this. Now let's look at the denominator. What's the probability of being a woman? Well, being just a woman is 350 over 660. So if I take 350 over 660, the 660 cancels, right? You know that's kind of algebra 1. If you have A over B divided by C over B, the B cancels. Why? Because this is A over B times, reciprocate the second fraction, reciprocate this here, and change division into multiplication, and notice B cancels. So you just get A over C. The B cancels. So if I cancel 660, I will get 60 over 350, which is exactly what I got here. So you can either use the formula, or since you have a table or Venn diagram, start with the women, start with the given, and find how many of them are girls. Okay? And that's quick. That's really quick. All right? So I'm going to give you an assignment, and starting today, I'm going to start giving you brain teasers for fun. Some of you know about my brain teasers. So you don't have to do this at all. It's not expected. But every time I do a video, I'm going to throw in 1 or 2 brain teasers for fun, okay? You don't have to do this, okay? So let's start with the assignments. So I actually called the director of the summer school to get numbers, but I didn't get a response, so I made up numbers. So assuming the MS Squared program, you have the following configuration. You have first year, second year, third year, and you have boys and girls. And I'm asking you to evaluate a bunch of stuff. Please do not start this until you find the numbers on the margin, the stuff in blue. Because if you don't do this, you're not going to be able to find the probabilities. So please recreate a table, nice table on your homework. Extend your margins and find those 6 numbers. 1 here, 1 here, 1 here, 1 here, 1 here, and the grand total. That's the very first thing you need to do. And then evaluate these questions. They are very similar to the ones I just did. But for example, on the very first question, which is to find the probability of being a boy, I don't want to see this. I don't want to see 20 over 41, which is actually the right answer. This means nothing to me. You gotta rewrite the question. Probability of being a boy, and then you say, okay, how many boys do we have? We have 25 and 32 and 20, so that's 77, I believe. Yeah, 77 divided by the grand total. I don't know what's the grand total. Okay, so please don't just give me this answer. Write down the probability of the event equals and find that percentage. That's quotient, and you may want to turn it into a percentage just like I did here. Okay, because this is much more visual. I say, what's the probability of a girl given that it is, graduate studies given that it is a woman? This doesn't that doesn't sit well with me. I don't know what that is. But in here, I know what that means. It's almost a fifth, right? It's 17.14%. So giving these percentages are actually very helpful. So just go through these quick questions. 1, 2, 3, 4, 5, 6, 7, 8. I gave you the conditional probability backwards. And you shouldn't get the same answer on these two, okay? So it shouldn't take you more than 10 minutes. And then have fun with this. How many times can you subtract 5 from 20? 20, okay? So these are sometimes silly, sometimes kind of intelligent. You don't have to do much math at all, but you have to think outside of the box. And you're not allowed to cheat. You know, like some of them I made up, but I didn't make up all of them. Some of them I've seen before. So you want to really just take a look at this. And for example, many of you will say, how many times can I subtract 5 from 20? Well, 4 times, right? Well, that's not correct, okay? So I want you to think through this. The second one is, I gave you a sequence, which is just a list of numbers. And I'm asking you to identify the next term in the sequence. Now, don't do any math. We're not doing anything serious. None of these requires math at all. So the first 5 terms are 1 and 11 and 21 and 1,211 and whatever. 1,011,221. No math is required. You just have to think outside of the box to try these. Again, you don't have to do these, but I do expect you to do the assignments. All right? Have a wonderful day.